Welcome back to our study of differential equations. And while I thought I had cut my last video, I realized there was a problem I wanted to show you in the last video and I missed it. So one little short video here. And here, let's read this a minute. Read this together. This could be right off a free response problem. It says the particle's velocity is modeled as... Okay, so here's my velocity equation. Then it tells me the particle's position at time equal to 1 is -3. Find the particle's position at t equal to 3. Okay, well, first of all, this could be right off a piece of a question from a free response problem in an AP test, and you'd have to recognize that this indeed is a differential equation. If you want the particle's position, I basically want to find x of t. I want to find x of t. And how is x of t related to v of t? Well, v of t, right, is equal to dx dt. It's the derivative of the position. And what's that equal to? That's equal to t squared sine of 5t. So yes, indeed, I do have a differential equation here. I got a derivative and an equation. In order to solve this, to get a particular solution, I need a point on the curve. Well, did they give me that? Oh, yes, they did. Here we go. There's the point on the curve. They're saying x of 1 is equal to -3. What are they asking for? Well, they're not really asking for x of t. They're asking for x of 3. But anyway, I could find x of t and plug into it. The first thing I have to do, I need to solve this guy. Solve this differential equation. And I'd say I'd separate, and I'd get t squared t dt. Okay, and then I'm going to integrate both sides. X of t is equal to... Ooh, and here's where I get into problems here. That's not an easy integration. And if I check my free response and I'm in a calculator section, I'm in an active calculator section, well, I might think, well, I could use the fundamental theorem to solve this. Even if it was easy to integrate, using my calculator might be a lot faster. But in this case, I do not know how to integrate this. I'd have to use integration by parts twice, which is not part of the Calculus AB curriculum. Okay, so anyway, remember what we just set up in the last video. I want to do what? Well, I want to integrate this from where I know it. I know it at 1, right? I'm going to go from 1 to t squared sine of 5t dt. Again, as I like to do this, if I plug this t, if I plug any t into here, if I plug in 1, if I plug in t equal to 1, I integrate from 1 to 1, well then this should be 0. But I know x of 1 is not 0, but x of 1 is -3. So how do I make this work? -3. By putting a -3 out here. And right here, now I've got an answer. You give me a t that you're looking for, I'll give you an answer. Does this solve this differential equation with this initial condition? It sure does. If I take the derivative of this, I'm going to get this. Check. By the fundamental theorem. If I put in 1 into this equation, I also get the initial condition. Okay, well that's good. Now another thing is, what's the question asking me for? It's asking me for x of 3. So x of 3 is merely going to be the integration from 1 to 3, the interval from 1 to 3, t squared sine of 5t dt -3. This is not, the -3 is not in the integral. So let's keep that in mind. I'll extend the page here. Let's get our calculators out and see what's going on. I'll be right back with the answer. Okay, I went to my trusty old calculator here, and this integral became 1.6403 minus 3. Bring down the 3 down here. And so my answer is going to be minus 1.3597. Okay, so if I'm going out to 3 significant digits, I'm minus 1.360. Okay, so where's the position of this particle? It's to the left of the origin by 1.36 units. Okay, so remember to look at this. These turn out to be very hard problems on AP tests. You look at this, first of all, you have to recognize the relationship between velocity and position. If you recognize it as a differential equation, okay, write it as formulate it as a differential equation, try to solve it, and when you're solving it, you realize you need to use the fundamental theorem to get to an answer and then to use your calculator. So if you get this one, you will be in very good shape. And it's not that it's a hard problem. I don't think it is. You need to recognize it, though, and then solve it. Okay, see you soon. Bye-bye.